In this video, we will discuss Section C of Sample Question Paper for the Board Exam 2024-25 Class 12 Mathematics as released by CBSE Board. Section C comprises of 6 short answer type questions of 3 marks each. So you can get maximum 18 marks from Section C. Hello friends, welcome to channel Number Collage. This channel is dedicated to videos on a wide range of mathematical concepts and problems related to them, ranging from high school math to engineering math. Effort has been made to explain the concepts through basic mathematical ideas in a simple English. Hope you will like my effort. Thank you. Question number 26. A kite is flying at a height of 3 meters. Here A is the position of kite and it is at a height of 3 meters from the ground and 5 meters of string is out. That means Y is 5 meter. If the kite is moving away horizontally along CB at a rate of 200 centimeter per second, which will be 2 meters per second, dx by dt, we have to find the rate at which the string is being released, that is dy by dt. Now in right triangle ABC, y square is x square plus 3 square 9. Differentiating with respect to time t, 2y dy by dt equals 2x dx by dt plus 0. Putting the values, 2 into 5 dy by dt equals 2 times x, which is 4 according to Pythagorean triplet, 3, 4, 5, and dx by dt is 2. So dy by dt will be 16 upon 10, 1.6 meters per second, that is 160 centimeter per second. So this is the rate at which string is released. Question number 27. According to a psychologist, the ability of a person to understand spatial concepts, that is, concepts related to space, is given by A equals 1/3 square root t, where t is age of person in years, and this age is between 5 to 18. We have to show that the rate of increase of the ability to understand spatial concepts decreases with age in between 5 and 18. The ability is defined as A equals 1/3 square root of t. Differentiating with respect to t, we get rate of understanding with t, that is age, is 1/3 into half into t raised to half minus 1, that is minus half, which will be 1 upon 6 into 1 upon square root of t. Differentiating once again with respect to t, d2a upon dt square will be 1 upon 6 into minus half into t raised to minus half minus 1 minus 3 upon 2. That will be minus 1 upon 12 into 1 upon t raised to 3 upon 2, which will be minus 1 upon 12 into 1 upon t into square root of t, which is negative for any age t between 5 and 18. Second derivative being negative, we conclude that the ability to understand spatial concepts decreases or slows down with age in between 5 and 18. Second derivative negative. Question 28a. An ant is moving along the vector L1. This one. Few sugar crystals are kept along the vector L2. This one with sugar crystals, which is inclined at an angle theta. This one with vector L1. Then we have to find angle theta and also find the scalar projection of L1 bar on L2 bar. We have angle between two vectors cos theta equals scalar product of two vectors L1 dot L2 upon magnitude of L1 into magnitude of L2, which is L1 dot L2 upon magnitude of L1 square root of 1 square 1 plus minus 2 square 4 plus 3 square 9 into square root of 3 square 9 plus minus 2 square 4 plus 1 square 1, which is 1 into 3 3 plus minus 2 into minus 2 4 plus 3 into 1 3 upon square root of 14 into square root of 14, that will be 10 upon 14 5 upon 7. So that gives angle between L1 and L2 theta equals cos inverse of 5 upon 7, the first answer. Next we have to find scalar projection of vector L1 on vector L2, which is vector L1 dot vector L2 upon magnitude of vector L2, which is 3 plus 4 plus 3 10, as found here. 10 upon magnitude of L2 is root 14 as found here. So this is scalar projection of L1 bar on L2 bar, 10 upon square root 14. Question 28b. We have to find vector equation and Cartesian equation of the line that passes through -1 2 7 and is perpendicular to these two lines, this one and this one. We will name 2 I cap plus j cap minus 3 k cap and I cap plus 2 j cap plus 5 k cap as A1 and B1 respectively. Similarly, we will name this 3 I cap plus 3 j cap minus 7 k cap and 3 I cap minus 2 j cap plus 5 k cap, this one, as A2 and B2 respectively. Now the line perpendicular to these two lines has a vector parallel is given by, say, B bar, which will be B1 bar cross B2 bar, because B bar will be perpendicular to the plane containing B1 bar and B2 bar, which will be determinant I cap, j cap, k cap 1 2 5 3 minus 2 5, which is I cap times 10 plus 10 20 minus j cap times 5 minus 15 minus 10 plus k cap times minus 2 minus 6 minus 8. So B bar will be 20 I cap plus 10 j cap minus 8 k cap. Now the required line passes through point -1 2 7 and is parallel to vector B bar. So its vector equation will be R bar equals, from this point we will write vector A bar, which will be minus I cap plus 2 j cap plus 7 k cap plus some constant theta times B bar 20 I cap plus 10 j cap minus 8 k cap, and its Cartesian equation will be x minus this minus 1 upon this 20 equals y minus this 2 upon this 10, which is direction ratio of vector B bar, equals z minus this 7 upon minus 8, which finally will be x plus 1 upon 10 equals y minus 2 upon 5 equals z minus 7 upon minus 4. After removing common factor 2 from each of these TRs. So this is the vector form and this is the Cartesian form of the required line. Question 29b. We have to evaluate this integral where n is a natural number. First we have to simplify this integral and then we will solve it. So the given integral is, that will be integral from 0 to 1 minus x into 1 minus x raised to n dx. Here we have applied the rule of definite integral. Integral from 0 to a f of x dx is equal to integral from 0 to a of f of a minus x dx, which means we have to replace each of these x by this 1 minus x, just like here, so that this integral will become from 0 to 1 minus 1 is 0, and this will be x raised to n into 1 minus x dx. After expansion, integral from 0 to 1 x raised to n dx minus integral x raised to n plus 1 dx. Now we will solve these two integrals separately. Integral x raised to n is x raised to n plus 1 upon n plus 1 from limits 0 to 1 minus integral of x raised to n plus 1 is x raised to n plus 1, that is x raised to n plus 2 upon n plus 2 from limits 0 to 1, which will be 1 upon n plus 1 into 1 raised to n plus 1 minus 0 minus 1 upon n plus 2 into 1 raised to n plus 2 minus 0. This will be 1 upon n plus 1 into 1 raised to n plus 1 is 1 minus 1 upon n plus 2 into 1 raised to n plus 2 is 1. This will be n plus 2 minus n minus 1 upon n plus 1 into n plus 2 will be n square plus 3n plus 2. N minus n is 0 and this will be 1 upon n square plus 3n plus 2, the given integral. Question 30. Consider following LPP. We have to minimize objective function z equals x plus 2y subject to the constraints this one, and these two. We have to show graphically that the minimum of z occurs at more than 2 points. First, we will draw the line 2x plus y equals 3 by first putting x equals 0 and getting y correspondingly. That gives 1.0, 3 on y-axis, and after that putting y equals 0, we will get x equals 1.5, thus getting a point 1.5, 0 on the x-axis. By plotting these 2 points, we draw the first line 2x plus y equals 3. Secondly, we will draw line x plus 2y equals 6. For that, we will put x equals 0 and will get corresponding value of y to be 3 and getting our first point 0, 3. Next, we will put y equals 0 and get corresponding value of x to be 6, thus getting second point 6, 0. And we will plot these 2 points and draw the second line passing through them, which is x plus 2y equals 6. After having drawn these 2 lines, we will find the feasible region. For that, in the first inequality 2x plus y greater than or equal to 3, we will put x equals 0, y equals 0, so that the region of this constraint to be non-origin side of line 2x plus y equals 3. Similarly, for the second constraint x plus 2y greater than or equal to 6, we again will put x equals 0 and y equals 0, getting the region to be again non-origin side of the line x plus 2y equals 6. Next, x and y both greater than or equal to 0 gives region in the first quadrant, and the common region, which is going to be feasible region, is shown here, which is unbounded and whose corner points are a 6, 0 and b 0, 3, and we will check this objective function z equals x plus 2y at these corner points. The value of z at 6, 0 is 6 and value of z at another corner point 0, 3 is also 6, which shows that minimum value of z occurs at more than 2 points at 6, 0 and at 0, 3. We get the same value of the objective function 6. Question 31a. The probability that it rains today is 0.4. From this we can write probability there is no rain today will be 1 minus 0.4, 0.6 being a complementary event. If it rains today, the probability that it will rain tomorrow is 0.8. This we write as probability of it rains tomorrow is given to be 0.8. From this we write probability that there is no rain tomorrow will again be 1 minus 0.8, 0.2 being a complementary event. If it does not rain today, the probability that it will rain tomorrow is 0.7. This we write as if no rain today, then the probability that it will rain tomorrow is given to be 0.7. From this we can write If no rain today, then probability that there is no rain tomorrow will be 1 minus 0.7, 0.3, again being a complementary event. P1 denotes the probability that it does not rain today. So we denote 0.6 to be P1. P2 denotes the probability that it will not rain tomorrow if it rains today, which means this 0.2 is P2. P3 denotes the probability that it will rain tomorrow if it does not rain today, which means this 0.7 is P3. And P4 denotes the probability that it will not rain tomorrow if it does not rain today, which means this 0.3 is P4. Question 1. We have to find the value of P1 into P4 minus P2 into P3. Putting the values, we get 0.18 minus 0.14, 0.04, the first answer. In the second question, we have to calculate the probability of raining tomorrow. In above discussion, we find that probability of raining tomorrow depends on whether it rains today or whether it does not rain today. So this is a case of conditional probability. For the second question, we have probability that it rains today equals 0.4 and probability that there is no rain today is 0.6, and the conditional probabilities as have been given are probability that it rains tomorrow provided it rains today is 0.8 and conditional probability that it rains tomorrow provided there is no rain today is given to be 0.7 above. Now based on this information, we will write probability that it rains tomorrow equals 0.4 from probability that it rains today, number 1, into 0.8 from the conditional probability that it rains tomorrow provided it rains today, number 2, plus 0.6, which is the probability that there is no rain today, from 3 here, into 0.7, the conditional probability that it rains tomorrow provided there is no rain today, number 4 here. This will be 0.32 plus 0.42, 0.74, which is the required probability that it rains tomorrow. The second answer. Question 31b. A random variable x can take all non-negative integral values, and the probability that x takes the value r is proportional to 5 raised to minus r. We have to find probability when x is less than 3. It is given that p of random variable x equals r is proportional to 5 raised to minus r, which we write as p of x equals r equals k times 1 upon 5 raised to r, where k is a non-zero constant of proportionality. Now probability when x equals 0 will be k times 1 upon 5 raised to 0, which will be k. Probability when x equals 1 will be k times 1 upon 5 raised to 1. Probability when x equals 2 will be k times 1 upon 5 square. Probability when x equals 3 will be k times 1 upon 5 cube, etc. Now we have probability when x equals 0 plus probability when x equals 1 plus probability when x equals 2 plus probability when x equals 3 plus so and so forth equals 1, because sum of all probabilities is 1. Now we will substitute the values from here which we have already found out. So this will be k times 1 upon 5 raised to 0 is 1 plus 1 upon 5 raised to 1 plus 1 upon 5 square plus 1 upon 5 cube plus so on and so forth equals 1. Now in this series there is geometric progression. Common ratio r is 1 upon 5, which is less than 1, and we have sum of all terms of a GP as a times 1 minus r raised to n upon 1 minus r. So that will be a, the first term, 1 here, so 1 into 1 minus r is 1 upon 5 raised to n upon 1 minus 1 upon 5. This will be 1 into 1 minus 1 upon 5 raised to n will be 0 because r is less than 1 upon 1 minus 1 upon 5 is 4 upon 5. So this will be 5 upon 4. So from this statement 1 we get k into 5 upon 4 equals 1. That gives k equals 4 upon 5. Now we have to find probability when random variable x is less than 3. That will be probability when x is 0 plus probability when x equals 1 plus probability when x equals 2. From the values that we have obtained, this will be k times 1 plus 1 upon 5 plus 1 upon 5 square, which is 4 upon 5 into 25 plus 5 plus 1 upon 25, 124 upon 125. So this is the probability when random variable x is less than 3, 124 upon 125. Friends, if you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.